Okay, this is a video lecture for Math 110, and this video lecture is for Monday, April 13th. And the topic today is simple interest. Now, what are we talking about here, and what's the motivation for talking about simple interest? If you guys remember the last few classes, we've been talking about sequences and series. And then we talked about a particular type of sequence called an arithmetic sequence, okay? Simple interest has to do with a financial application, which has to do with simple interest investments or loans. It turns out simple interest investments are very closely related to arithmetic sequences, which is why we're doing this after arithmetic sequences. And then after this class, we're going to talk about another type of sequence called a geometric sequence. And after that, we'll talk about what are called compound interest investments. And it turns out compound interest investments are very closely related to geometric sequences. So these topics of simple interest and compound interest very naturally fit with sequences, arithmetic sequences, and geometric sequences. And the motivation for talking about simple interest is when you guys go out and graduate, you'll very likely encounter simple interest loans. So an application is loans. And you'll also encounter investments, which are simple interest investments, simple interest loans. In fact, most mortgages for houses, which is basically loans from the bank so you can buy a house, those are simple interest loans. So it's important to understand simple interest when you guys go out in life, so you understand the types of loans you would be getting, and you can actually know what you're talking about when you talk to the bank. Okay. So what I want to do here is I want to consider an example. We're going to consider a very, pardon the pun, simple example of a simple interest investment. And what we're going to have here is suppose we're investing $1,000 into an account. And this account will be earning an interest rate of 10% every year. So imagine you're investing $1,000 into an account. And then every year you earn 10% interest on that $1,000. By the way, just to introduce you guys to some terminology, this initial investment is called the principal. Okay, and this 10% is called the interest rate. And what I have here is a table, and we're going to calculate the value of this simple interest investment over time. In year 0, this is basically the starting year. And I have some columns here: the year, the interest earned, the accumulated interest, and the value of the account. In year 0, there's no interest earned, there's no accumulated interest, and the value of the account is simply $1,000 because that's your initial investment. It gets more interesting when we start going to subsequent years. So let's look at year 1. In year one, how much interest do we earn? Well, the way this works is to calculate the interest earned, we take 0.10. We take our interest rate, remembering not to plug in a percentage, but plug in the decimal equivalent, which is 0.10. We multiply that times our principal of $1,000. Okay? 0.10 times $1,000. And this gives us an answer of $100. Should put dollar signs here. So in our first year, we earn $100 of interest. And then our accumulated interest is basically the sum of all the interest earnings we've had. This is simple here as well. This is just $100 because we just had 1 year of interest earnings. Okay, so after year 1, I've earned $100 in interest. What's the value of the account? Well, the value of the account is actually $100 plus the original principal of $1,000, and this equals $1,100. So after year 1, I have $1,000 of principal and $100 of interest earnings, which gives me $1,100. By the way, this interest rate is a really good interest rate. You'd be hard-pressed to get this kind of interest rate out in the real world, but the reason I'm using it is it makes our calculations simple. Let's go to year 2. In year 2, how much interest do we earn? Well, it's the same formula. In year 2, we multiply the interest rate times the principal, and this gives us $100. So in year 2, we earn $100, okay, of interest. What is our accumulated interest after year 2? The answer is it's 100 plus 100 because we earned $100 in the first year, we're earning $100 in the second. So my accumulated interest is $200. And what's the value of the account? Well, here, after year one, we had $1,100, but we earned $100 in year two. So the value of the account is $100 plus $1,100, and this equals $1,200. So after year two, we have $1,200 in our account. So this is simple interest. We're basically earning, every year we're earning 10% of the principal as interest. Let's go to year three. I'm going to skip I'm not going to go through the details of the calculation, but hopefully you guys can see in year three, your interest earnings are also $100. Okay, and it's the same formula. We're always earning 10% of the principal. The accumulated interest in year three is $300. Okay, and then we get the value by adding, there's two ways to do this. Either we could add $100 to the previous year's value of $1,200, or we could add the accumulated interest to the original principal. Either way, you get the same answer, and hopefully you guys see that the value of my account after 3 years is $1,300. Let's fill in the rest of this. The accumulated interest, the interest earned in year four is also $100. The accumulated interest is $400. And the value of my account after year four is $1,400. Okay. I'm going to pause there. We'll come back to year 50. But I just want to fill out these first 4 years. So this is a really simple loan investment and a very simple calculation of simple interest investment. Hopefully this makes sense to you guys. Now, what I want to do here is I've calculated the value of my account after year 1, 2, 3, and 4. But is there a way, if I said to you guys, calculate the value of the account in the 50th year or in the 111th year? Is there a simple way to calculate that without having to go through all the previous years, without having to create a table? Is there a simple formula I could use to calculate the value of a simple interest investment? And the answer is, the good news is, yes, there is a simple formula. And we're going to derive this formula right now. So let's look at, what I want to do is list out the value of my account starting with year one. Let's list out the different values, okay? And we start with year one. So I have $1,100. After year two, I have $1,200. After year three, I have $1,300. After year four, I have $1,400 and $1,500, and so on. Okay. Now let's look at this. This is actually a sequence. This is a sequence, right? This term is A1. This is A2. This is A3. This is A4, and this is A5. This is a sequence. Okay. What kind of sequence are we dealing with here? If you look at this sequence, you'll see, if you remember from last class, this is simply an arithmetic sequence. This is an arithmetic sequence. This is an arithmetic sequence because each term is obtained by adding a fixed amount to the previous term, right? For instance, $1,300 is obtained by adding $100 to $1,200. So this is an arithmetic sequence. As we always do with a sequence, let's identify A1. A1 for this arithmetic sequence is $1,100. And let's identify the common difference, D. The amount we add to each term is $100. So all we have here, so a simple interest investment, the values of the investment year by year, is an arithmetic sequence. If you guys remember last class, we derived a formula we can use to calculate the value, to calculate the term AN. So if you want to calculate any term of an arithmetic sequence, AN is equal to this simple formula, A1 plus D times N minus 1. So that's a formula we can use. And what I want to do is I want to apply this to this sequence. So in other words, AN for this particular sequence, AN is equal to A1, which is $1,100, plus D, which is $100, times N minus 1. Okay. And where N is the year. What I'm going to do, this is nothing earth-shattering here. I'm going to replace N with T. Excuse me, this is 1100. Oops. I'm replacing N with T. Don't lose any sleep about that. The reason I did that is it turns out our index n is simply the year that applies to our account. So I'm just replacing n with t, because in this case n is time. N is equal to t, which is the year, which is time. So I'm going to replace n with t. Okay, and this is what I have. Now what I want to do is a little bit of arithmetic on this. And what I do here is I can write this as AT equals 1100. I'm going to distribute here. So I get 100. If I distribute here, I get 100t. 100 times t, and then I get 100 times minus 1, which is minus 100. Okay, and then I'm going to combine these two terms. So 1100 minus 100 is simply 1000. Okay, and so I get this formula for just a little bit of algebra. I get a formula for the value of my account as a function of year. So if for instance, you were interested in the 15th year, t would be 15. You'd plug in a sub 15 equals 1000 plus 100 times t. Okay. Now what I want to do is talk about this. I'm going to erase this table. Do I want to do that? I think I do. I think we've gotten everything we need from this table. So I'm going to erase this table. I may regret that, but I don't think so. Oh, the 50. I was regretting the 50. Well, we'll fill that in a second. I'm going to erase this table. Shoot, this eraser's not working too great, but anyway, so be it. Let's look at this formula, and let's identify. I'm going to rewrite this. AT equals 1000 plus 100t. Okay, let's look at that formula. Let's identify things here. What is this 1000? What is this 1000? The truth is this 1000 is our principal, P, right? You guys remember that? I think I erased that, but the $1,000 is our initial investment. That's known as the principal. This is the principal. And that's denoted with the letter P, okay? Let's look at this, $100. What is this $100 equal to? Well, what this $100 is equal to, if you remember, it was 0.10 times 1,000. 100 is 0.10 times 1,000. Well, what is this 0.10? This is our rate. This is our rate. And we're going to denote that R. What is this $1,000? This is our principal P. So I'm taking this formula, identifying what different aspects of it equal, and then I'm going to rewrite this now. So AT is equal to, replacing the $1,000, we know this is our principal. AT is equal to the principal, okay, plus, and this $100 is simply R times P. This is R times P. It's the rate times the principal. So I get a principal, $100 is the rate times the principal. And then left over, I have a t here. Now I know this is a little bit of mathy derivation. I wouldn't ask you guys to reproduce this derivation on a test. I might not give it as an extra credit though, but I think it's helpful to know where this formula comes from. Okay, so this is what I get. And then what I'm going to do is, you guys remember factoring. I'm going to factor out the p, and I get this formula. If I now have a principal here and a principal here, so I'm going to pull out the p, and I'm left with p times 1 plus rt, okay? And I'm going to box this formula. This is our magic formula. This applies for simple interest investments. This applies to simple interest investments. Let me write down what these symbols mean. AT is the value of the account, after year t, and P is the principal. In other words, it's the initial investment. Okay, R is the interest rate, and T is the year, or it's the time. So this is now a formula I can use if I have a simple interest investment and I know the principal, initial investment, and I know the interest rate, I can calculate the value of this simple interest investment in any year by using this formula. Okay, that's the theory behind simple interest. Let me do a couple example problems with you guys so you can see how to use this formula. Let's erase here. I don't know why it's not erasing properly. There's a little bit of black left, but you guys can hopefully still read the board. And we'll just do an example problem here. So here's the example problem. Okay, let's imagine we have an investment. So suppose you guys invest $15,000 in an account that earns an interest rate of 8%. So you have $15,000 to invest. You invest it in an account that has an interest rate of 8%. Okay? And we're going to ask ourselves some questions about this account. And the first question is, what's the value of the account? What's the value of the account after 10 years? What's the value of the account after 10 years? We're going to use the formula we just derived for the value of a simple interest investment is equal to principal times 1 plus RT. Okay? That's our basic formula. And now we're basically going to plug in numbers here. So we know our principal is $15,000. We know that the rate here is 8%, but we need to remember to convert that to a decimal. So we plug in 0.08. Okay? And now what's the time here? Well, the time is 10 years. We're interested in the value of the account 10 years in the future. So we plug in 10 here. And let's finish this calculation. We get $15,000 times 1 plus, and here we have 10 times 0.08, that equals 0.8, right? And then one important thing here is order of operations. We first need to add what's in parentheses before we multiply it by 15,000. So now we have 15,000 times 1 plus 0.8 is 1.8. And if we plug this in our calculator, we get $27,000. Okay, so this is a classic simple interest problem. We've calculated the value of our account after 10 years. The value will be $27,000. A second part of this problem has to do with how long it'll take this account to triple in value. Okay, how long to triple? Okay, how long will it take this simple interest investment to triple in value? If this account triples in value, that means the future value AT of this account. If it triples in value, the future value will be 3 times 15,000, which will equal 45,000. So if the account triples, it's worth $45,000. Now I'm going to use this formula again here. I'm going to plug into this formula. But in this case, I actually know the future value. The future value of the account is $45,000. Okay, that's the future value. Okay, the principal is $15,000. That remains unchanged. And then I have 1 plus. The interest rate is still 0.08. But now here's the thing. Now I don't know t, right? I know the account triples in value, but I don't know how long that takes. So I have to just plug in t as t. And actually, t is what we're solving for here. T is what we're solving for in this problem. How do I solve for t? Well, what I can do is divide both sides of this equation by 15,000. And that leads to 15,000 divided by 15,000 is 1. 45,000 divided by 15,000 is 3. So this equals 3, right? So now I have 3 equals 1 plus 0.08t. Okay? That's what this equation simplifies to. I want to solve for t. The next step is to subtract 1 from both sides. If I do that, 3 minus 1 leaves me with 2. 1 minus 1 leaves me with 0, so I get 2 equals 0.08t. Okay? Final step is I divide both sides by 0.08. Okay, these cancel out, and I'm left with t equals 2 divided by 0.08. And if I plug this in my calculator, I get 25 years. So it takes this account, this simple interest investment, 25 years to triple in value. Now, does this answer make sense to us? Well, after 10 years, it had a value of $27,000, which is not quite double the account. So it makes sense that it would take a little bit longer than 2 times 10 years for this account to triple in value. So it almost doubled in 10 years. It makes sense that it takes 25 years for it to triple in value. And so this answer makes reasonable sense. This is a classic simple interest investment problem. Well, this concludes the video. If you guys have any questions, or I'll look forward to talking to you guys on Monday, April 13th, and we can go over any questions you guys might have about this, do a few more practice problems, and also go over the homework that's due then. So I'll see you then. Thanks.